Okay, I'm going to make this as interesting as I can without being boring. Negative mass at the speed of light equals energy over gravity equals mass at the speed of light squared. And on a quantitative level, it looks like this. Z, X, Y. Because, just like Newton said, F equals ma, which, and then it's 3 laws. Okay, so this is kind of difficult to explain, however very interesting. Okay, let's take energy. You can say that energy, mass, and the speed of light squared. So what we have here, okay, now this is relevant because this here depicts magnitude, space, and quantity in different forms. It depends how the viewer looks at it. So, fuck, that ain't gonna work. Well, it is, but alright, so we'll continue on here. So, based on this here, because you have magnitude and something else there, based on this here, which is quanta, because you have quantitative structure, and just like that. But however, this depiction of quanta actually it's just a 50-50 view, and it's actually more like infinite point of curvature, like magnitude is, for example, where you have a black hole in the event horizon, or if you look at the other side of the coin on that, you have a radiant star with nuclear fission occurring. Okay, so then, yeah, but this is actually, it's infinite point of curvature, but it has, you can see the start in the beginning, and it just keeps going round and round. It has its own Z, X, and Y axis. Now to prove this, we can decode Einstein's theory of energy equals mass speed of light squared. Okay, that's the theory of relativity. We all know there's a special theory of relativity that goes along with that, but we'll just take this. Energy, mass, and the speed of light. So what we do is we say, okay, energy is equals Y, which is this Y is up here, when we have our Z here and X here, and then we can say that what are we looking at? Energy equals mass and the speed of light squared. So we say speed of light squared equals x-axis, because x-axis is time, and then z-axis equals energy, so mass, because z-axis is quantitative state, because you can't have quantitative state without space to occupy that quantitative state and the time it takes to move through it. So here we have, we've basically broken this down, so how it fits into here. But then you say, hey Mark, what's going on? How can energy be space and when it's occurring like this? So we go, oh yeah, okay, well, and this is exactly how this works. Okay, is that then you do a 1/4 axis spin, like you have magnitude up here, this here is magnitude, this here is quanta, and then you have normal x, y, and z axis, like Euclid said. Euclid. Right, so then here, and then what you have here, which is primary foundations for this, and then you go, well, okay, well, let's say that, how can that be if mass is the only thing we can see? And you're saying that these two things, which are exact opposites of each other, and space is what occupies those equal and opposite things, or just like Newton said, F equals ma in uniform motion, every action has an equal and opposite reaction, and it's just funny how that there has just that there, and it just fits nicely into all of that there. Okay, so being real excited about this. Okay, so then you say, well, okay, how does that work? Well, it works like this. Okay, because then you say, well, this here, this is this is one x, y, z axis. This is one point in time. This is that one point that the viewer looks at, and you say, well, but there's more to the time that you're taking one point. So how all this makes up what everything, the whole nine, how it all exists and how everything works, is you do this. Is you say, okay, well, in this form here, energy is the space that occupies, and speed of light squared is time, and z-axis is mass. We say, well, mass is the only physical object there, and mass occupies space. So then you go, okay, well, in that instance, y then equals mass, and then it has, through here, that y-axis has another z and x-axis. Oh, z and x-axis right there, that runs through that. And then you say, well, okay, because mass now is the common denominator, and energy and the speed of light squared, you can't actually see them, but you know that they exist. So that is where that x, y, z axis comes into place, which is pretty much that there. Okay, and then when you take that again and look at that, okay, then this here has, this z axis has an x and a y axis attached to